Lesson 3.5, solving quadratic equations by completing the square. So we're still solving quadratic equations like we have for last few lessons. We still got the form something like x squared plus bx plus c equals 0. This is common form. There might be an a term in front of here. We'll get to that later. Right? And we're trying to solve for x. Right? So you see different methods. You could always jump to a quadratic equation. That'll always get to you if you're ever in a jam. But there's a particular method here that's kind of interesting. So you're getting something in the form here. It looks like this. Something plus something quantity squared. And I'll leave the plus c equals 0 over here. Okay? So how could you sort of like unfactor this bit right here, this x squared plus bx, so that um, you can continue on your way to solve it. Now notice I'm being pretty abstract here. Like x can be a variable, that's fine. We're solving for x, right? That's not strange. But instead of giving you numbers and leaving it as very generically b and c, if that's a little confusing, don't worry because we'll jump into examples with actual numbers pretty soon. But I want to start real generic. Right, so broad picture here. The method goes like this. So if I do x plus b over 2, right? Okay, now there's a little more to it, but let me pause right here. Now, what does this actually look like if I expand it out? Right, so something squared, isn't that something times itself? Okay, and I'll leave the plus c equals 0 over here. I left a little gap here intentionally. Go back to later. Okay. Isn't this x plus b over 2, x plus b over 2? Okay. Now, if you FOIL this out, so you're working backwards to check your work, right? Because we did factoring. Did I correctly factor this? Well, if I FOIL this, f O I L. It should lead me back in. Everything should be correct. We have to spell that out. First, outside, inside, last. Let's see how this compares. So x times x is x squared. Bing. Okay, so good so far. Now, x times b over 2 plus x times b over 2. Well, that gives you bx. Bing. Ah, so that's why that works. If you want to, well, where did I get the b over 2 from? Oh, okay, well, right. The outside and inside terms would add up to the original bx term. Okay, okay, okay. But here's the catch is what about this last term? Isn't that b over 2 times b over 2? Where is that? That's like b over, that's like, that would be b squared over 4, and it's like excess. We don't really want that. So I can restore balance by simply subtracting it out. Say minus b squared over 4, and I'll do the same thing up here. Minus b squared over 4. Okay? Now, some textbooks and teachers teach it exactly like I just did it. Some will instead say, actually, you can add it to the other side, plus b squared over 4. It's the same thing, right? Whether you subtract it on the left side or add it to the right side, it's the same thing. Right? So kind of a matter of preference, right? But yeah, this is equal to this is equal to this. So they're all the same thing. They're all the same thing, right? Right now, what you can do is here. I'll actually pick up from this step and continue this down. All right. So like, where does this adventure lead? Yeah, big picture point of view with the b's and the c's. Right? All right, so I've got an x plus b over 2, or 1 half b if you like, right? B squared, okay, equals, right? Actually, I can subtract all this over. So maybe add over the b squared over 4, which maybe if you preferred, you could have started with it over there anyway, and then subtract over the c, right? So it'd be like that, wouldn't it? And then I can continue on my way and solve for x if I want to solve for x. Right? So getting in this form, I effectively completed the square. Right? So completed the square. And then the extra bit in the title is solving the quadratic equation. So solving is like solving for x. So the extra steps would go like this. Well, how do you solve for x from this point? Well, now you can just square root both sides. So x plus b over 2 would be the square root of b squared on 4 minus c. Okay? It'd probably be a plus or minus, right? Because yeah, we normally do get two answers out of these quadratics, right? Right, one or two, or sometimes zero imaginary. So I'll do plus or minus, and then you can subtract it with b over 2. X equals negative b over 2, and then plus or minus square root of b squared over 4 minus c, right? And yeah, it's kind of splintered. This sort of is almost looking quadratic, isn't it? Right? Like the quadratic equation, x equals negative b plus or minus square root of b squared minus 4ac, and then all divided by 2a, right? I'm sure you can kind of fudge this and it would look like that, except I don't have an a term because I just left the coefficient in front of the x squared as 1. Okay? Now, what if there was an a? You'll see some of those examples later. Okay? But once you see how this all sort of connects. Right? All right, so then that would be the answer to x. And again, because this plus minus, I could get two solutions, as you would expect from quadratic. right, so let's jump into the book examples, and then I have some puzzles from the main part of the lesson highlighted. Right? So example one, solving a quadratic with rational roots. Okay, so real straightforward. And so pretty much exactly what I just did. This is example one, except it has numbers instead of letters. So a little more concrete example here. X squared minus 4x plus 4 equals 25. Okay, now we know this is quadratic because there's an x word in x. And there's also some other concept thrown in the mix. Right, we're trying to ultimately solve for x. And what is x? What is x? Right? And so let me try that whole method I just did. Again, if you want to subtract over the 4, just kind of get it out of the way or not really think about it. Here, I might do this. I might do x squared minus 4x. And here, I'll just go ahead and subtract it and make this 21. Right, get that out of the way. Here. All right, because it's this part that I want to sort of complete the square. Now, if I do that method I just did, I'll just be like x minus, let's see, what's half of 4? That would be 2, right? Right? Right, that squared. Right? But if I FOIL this out, FOIL out here, I'll write it a little bit differently just in case this helps visualize this. Isn't this? It's the same thing, x minus 2, x minus 2. Now if I FOIL that, FOIL, what does that produce? X squared, bing, negative 2x, negative 2x, negative 4x, bing. But negative 2 times negative 2, that's positive 4. So I have to subtract 4 to balance the equation. So that's also true up here. So this is what's equal to 21. Okay, something like that. Okay. Or I could, let's see, add over the 4. Oh, you know what they just did? I realized they even made this simpler than I realized. Okay. Because you could have left this 4 here from the beginning and just gone ahead and like factored it from there. That would have been even more straightforward. But that's okay. This is a more systematic approach to these type puzzles in this lesson anyway. X minus 2 quantity squared equals, and this would be 25. Okay, now this is an important middle step right here because this is the completing the square factored form. Okay, but there is a little more to it because you can still solve for x. So let's go and do that. So x minus 2 equals, well, how do you undo a square? Square root. So plus or minus 3, 25 which is plus or minus 5, I guess I should have done that. Right? And then finally add over 2. So x can be 2 plus or minus 5. Okay? Or x equals, here in curly brackets, go look at this. 2 minus 5 is negative 3. 2 plus 5 is 7. So that should be the proper answer. Okay? Okay. And just to show you this works, if you take either of these answers and plug it back to the original statement, you should get well, something equal to 25. Let's see if that's true. Okay, so if I do negative 3 squared minus 4 times negative 3 plus 4, I should get 25. Oh, yeah, 25. And if I replace that negative 3 with 7, I should also get 25. Let's see if that's true. Oh, yeah, double win. Oh, yeah. So we are on good footing. This is working. All right, so far I've given you one abstract example with B's and C's in it, and then a more concrete example with numbers. All right, what's the next example they have lined up? These get effectively more complicated as we're going. They jumped church. Irrational, so that's not bad. All right, so we'll just have some square root living numbers in the answer. That's all right. All right. So x squared plus 24x plus 144 equals 192. Yeah, you know what? I see what they just did. They did this back to back. They're really helping us out here by like what's half of 24? Is that 12? What's 12 squared? It is 144. So they're really helping us out. So I don't have to shuffle this off. I can just right away say x plus 12 quantity squared is this entire thing. Right? Maybe save some steps. Yeah, so yeah, saved a bunch of steps recognizing that 144 is half of this term, this coefficient 24 squared, or 12 squared. Right? All right, so we can solve it from here. All right, so x plus 12, right? Well, here's where it gets wacky, right? We're going to get it plus or minus the root of 192, right? But what is 192 in terms of primes? Well, I do see it's even. In fact, it's got to be multiple of 4 also. What's 182 divided by 4? Because 92 is a multiple of 4. So that'd be 4 times 48. And 48, isn't that 4 times 12? And 12 is 4 times 3. Okay. Right, so why did I break that down in terms of primes? Ooh, who would pause this? No. Okay, no, we're good. All right. Thought the recording was going to fail. No, we're good. Because, watch this, x plus 12 equals plus or minus the root of, okay, it's really all these multiplied, right? It's 4 times 4 times 4 times 3 underneath the radical like that. Like that is what 192 is. It's all that multiplied. Okay. Well, the square root of 4 is 2. So I can take this out as a 2, this out as a 2, this out as a 2. So really, yeah, it's like this. X plus 12 equals, I got a plus minus. It's 2 times 2 times 2. And then I still got the 3 underneath the radical, so that's okay. Well, this is all 8. So x plus 12 equals plus or minus 8 root 3. Okay? And then finally subtract over the 12. So x equals negative 12 plus or minus 8 root 3. Okay? Well, I'm kind of running out of paper, but you guys get the idea that you could do negative 12 minus 8 root 3 or negative 12 plus 8 root 3. Those would be two different answers right there, wouldn't it? Right, two different answers. Okay, is that, oh, yeah. Okay, that's exactly what the book got to. Okay, of course. Yeah. All right, so example 3. All right, let's hear solve quadratic. Oh, complex solutions. Okay, here we go. All right, complex means like imaginary. We're gonna get some eyes. Yeah, I'm seeing some eyes showing up. I said that's okay. You guys have done plenty with eyes in the last week. We got 2x. Oh, also, we got a leading coefficient on this x squared. That's interesting. Minus 92x plus 1058 equals negative 72. Right. The one thing I see right away is that these four terms are all even. It's okay if I do this. Like, I don't know if the book wants you to do this or not, but I won't even look at that. I'm going to say if I have four terms and I divide them all by two, I mean, that's perfectly valid. It'll at least get rid of that coefficient, right? That's one way to do it. And that looks more familiar. Oh, I should know this. 46. So 46x plus 58 over 2. 529 equals negative 36. Okay, let's see it. All right. Now, I've seen what they've done for the last couple examples. There's half of this coefficient squared is this number. Let me see if they did that again. Half of 46 is 23. If 23 squared is this number, then they're really helping us out. Yeah, they just did that 3 times in a row. Okay, so that's nice. Right. Might not always go like that, but we got some warm ups here. Right? So you can go x minus 23 squared is the same thing as all this right here. It's the same thing. Same thing. Right? So this is negative 36. Okay? Well, the fact that something squared is a negative, this is the point that you know for sure you're going to get some i's in the answer, some imaginary. Yeah. Okay, so x minus 23 could be, okay, so I just took the square root, so I have to do that both sides, plus or minus the root of negative 36. But here's where, okay, I know what the root of 36 is. That would be 6, okay, plus minus 6. But there's also an I because of this negative right here. So x minus 23 equals plus or minus 6i. It's the same thing. And now we got an I. Head over 23 and we got the answer. X equals 23 plus or minus 6i. Okay, so it could be 23 minus 6i or 23 plus 6i. Oh, okay, there you go. 23 minus 6i, 23 plus 6i. All right, we got both answers. Boom. What's next here? Example 4, completing the square. Find the value of c. Okay, so it's a little creative maybe. That makes x squared minus 7x plus c a perfect square. They write the expression as the square of a binomial. Let's try this. Example 4. All right, so I got x squared minus 7x plus c. Let's see, if I want this to be a perfect square, I'm thinking x minus, now half of 7 is like 3.5, or maybe I could write it as 7 halves if you like as a fraction. Okay. So if I square that, right, then it should be the same as this, right? Right. Now, if that's true, then see if I go expand this out, that would be x squared. So I'm foiling, so FOIL, x squared minus, hold on, my computer do something weird. Yeah, let me pause this and reconnect this internet right here. Make sure this is actually working. Okay, we're pretty sure this is working. We're here at like 8 o'clock at night. The internet's being a little dodgy right now, but we're gonna make this work. All right, so this would be, all right, then the outside inside would be this, so 30 to -7x. And then I would have plus 49 over 4, because that's what 7 over 2 being squared is. The negative doesn't matter because it gets squared. Okay? All right, so this would have to be my c. It's the same thing. So c equals 49 over 4. That should be the answer. And then, okay, this would be the, like this, how they write that? Square of a binomial. So I think like that. Let's see if that's what they're looking for. Um, yeah, got, okay. Well, it's funny is where they try to kind of guide you along. Well, okay, all right, I think go for something like that anyway. All right, example 5, solve by completing the square. Example 5. All right, so I got x squared plus 18x minus 4 equals 0. Right? Okay, now this one, I know well, half of 18 is 9. 9 squared is not -4. Okay, so this is a little different. Right? But this is more what I was doing right at the very beginning of the video. I'll do x squared plus 18x. Okay, I'll go ahead and just add the 4 over, right, just to get it out of the way. Now think about this in terms of like x plus 9 being squared, because isn't that x plus 9, x plus 9? Okay, so if I FOIL that out, here, I'll write it just in case it really isn't clear. Okay? This is the same thing as this, right? So x times x is x squared, bing. 9x and 9x makes 18x, that's your outside inside, bing. And then 9 squared is 81. So this is excess by 81. I have 81 too much. So I could either subtract it out to restore balance and say equals 4. Right? Again, you could add it to the other side. That's perfectly fine too. Right? And in fact, that's what I'll just do for the next step anyway. Yeah, or I'll just pick up from here. I just wrote this line just to make it more obvious what I was doing. Here, this and this are the same thing. Right, so x plus 9 quantity squared equals, and if I add over 81, 81 plus 4, which of course is 85, something like that, right? And so now I can go ahead and finish the rest of this solve for x. Okay, so this is a really important step right here. Right, really critical step. I've completed the square. Okay, and now I can move forward and solve for x. So square root both sides. So x plus 9 is okay, it's going to be a plus or minus root of 85. Right? What is 85 break down to? Like I see it's multiple of 5 and also 17. Okay. Now 5 and 17 are both primes, so I can't really pull anything out of the square root like I could before. Okay, so 5 and 17. Okay. Okay, so I'll just leave that one. Okay. And then, oh, whoops, I should just say plus here. Oops. Okay. It's just x plus 9. Okay. Let me rewrite that so it's really obvious. X plus 9 equals, just to get ahead a little bit. Okay. 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 And then subtract over 9. So x equals -9 plus or minus the root 85. Right? So it should be like that. Or I'll say approximately. So approximately, we get some approximations. What's -9 minus the root 85? -18.22. Or, and then if I do a plus right here, I'm getting 0.22. Okay, so if you went to the nearest hundred, it would look like that. Okay. All right. Example 6. Solve a problem by completing the square. Yeah. Jamal's parents are putting a rectangular swimming pool in their backyard. The length is 16 feet longer than the width. All right. Let me pause right there and get a picture. Example 6. The length is 16 feet longer than the width. And so we got the swimming pool. Right. All right. Okay, so we got some width, and we got this length, which is the width plus 16. It's the same thing. Okay? That's what length is 16 feet longer than the width means. Yeah, I think the internet's wigging out again. No, it's gonna work. Okay. All right. Yeah, I think it's still recording. All right. If the pool will cover 512 square feet, so area equals 512, well, square feet with units, right? I guess this 16 would be feet. Find the length and width of the pool. Right? All right, so there might be different ways you could set this up or think about it. Since the theme of the lesson is completing a square, that we could, well, navigate it that way. Right? So I know that area is width times length, or length times width would be like, right? Okay. So I'm going to say area is, right, width times, but then instead of length, I'll substitute this right here for length. So width plus 16. Okay. Furthermore, I know this area is 512 square feet. I know all that's true. Okay. So here, I'll go ahead and distribute this W and then substitute 512 for A. Okay. So 512 equals W squared plus 16W. Okay. All right, now this is looking a lot more traditional. Okay. Um, so complete the squared here, right? Okay, so I could say what's half of 16? That's 8. Right? Yeah, let me do this. I'll just want a little different. Okay. So half of 16 is 8. Could I do 8 squared is 64? Could I do it this way? Could I do plus 64 and plus 64? Right. I haven't quite done it that way yet, but some textbooks teach completing square like that. You get that right. So half of 16 is 8. 8 squared is 64. I added it to both sides to balance the equation. Okay. It's a little bit different way to get it. So you got 6, 7, 5, 576 by the way. That looks like a perfect square, I'm pretty sure. Okay. Equals, and then on this side, I can do this. W plus 8, or W plus 8 quantity squared if you like, same thing. Right? So square root both sides. What is the square root of 576 is 24. Yeah, a whole number 24. Right? So when I square root both sides, here, do that thinking. Square root, square root. Right? This side becomes 24. Maybe plus minus 24, but I think this 24 should suffice for positive dimensions of the swimming pool. And then the side of the square root of all that is just W plus 8. Okay. Last step, subtract over 8. I'm getting W is equal to 16. That would be feet, right? And the length, say if you want to both dimensions, isn't the length just W plus 16? If width is 16, it would be 32. 32. So the dimension should be 16 by 32. Right? And to check my answer, hey, couldn't I check my answer by saying if I multiply length times width, I should get back to 512 square feet? Let's see if that's true. Right? If it is, then we're definitely good. So what is 16 times 32? Yep, it's definitely 512. So we are good. That's the dimensions right there. Width and length. That's the dimensions. Example 7, solve when A is not 1, which we kind of ran into before. If I backtrack a little bit, we did, yeah, here, there was a coefficient 2 right there, right, which we just divided out right away. Right? And that's basically one way to solve that anyway. It's just say, well, if the coefficient is not 1, then you can just divide it out. So example 7. So we got 4x squared minus 12x minus 27. Okay. Again, it's equal to 0. We're solving for x, just like we have for other. Okay. Um, see, watch this. If I do divide by 4, divide by 4, divide by 4, I'm dividing all the terms by 4. So now that a coefficient is 1. Yay! It's just 1x squared. This is minus 3x now, right? 12 over 4, 6. And okay, and this is a funny looking term here, 27 over 4. Right? This is all equal to 0. You know what? Okay, now from here on out, there might be a little bit different ways to solve it, think about it, different paths in the forest. I'm just going to add this funny fraction over to the other side to get it out of the way. X squared minus 3x, and I'll say equals 27 over 4. Okay. Actually, how I want to continue this is the same way I just did the last one. Like half of 3 is 3 over 2, and if I square that, I know I would need that eventually by doing this completing square process. I'll just go ahead and add it in right here. So I'll do plus half of that b term being squared, and then I'll add that on both sides so I can sort of like balance the equation, right? Okay. As long as I add it to both sides, the equation is still balanced. And as long as I have it here on the left side, then I can very quickly factor this. Because this would be x minus 3 halves quantity squared. This is this. It's the same thing. Right? If you expand this out, if you FOIL this, x times x is x squared. Bing. Negative 3 halves x plus negative 3 halves x is 3x. Bing. And then 3 over 2 squared, regardless of the negative, because that gets squared, it's just positive anyway, is this. Bing. So it all checks out. Right? Now on the right side, you know what you do is actually go ahead and square this out over here, which gives me a nice common denominator, because 3 over 2 being squared, that's 9 over 4. So now I can add those fractions together. That's nice. Right? So I got x minus 3 over 2, all being squared equals, and then is that 36 over 4? Oh, hey, 36 over 4. That's 9, isn't it? That is 9. Yeah. All right. So it's working out. Okay. All right, so here's an important step. So we haven't actually solved for x yet, but we did get this in this factored squared form. Okay, so that's an important middle step. Yeah. All right, so now let's go ahead and finish this. So square root both sides. So x minus 3 over 2 equals this be plus or minus 3, because I just square rooted. Right, square root, square goes away. And then finally, x equals, I add over 3 halves, plus or minus 3. Okay. Well, I guess we could do a little more with this, right? Because isn't 3 equal to 6 over 2? Right, so that's 3 over 2 plus or minus 6 over 2. Okay. So if we did 3 over 2 minus 6 over 2, here I'll put little curly brackets. Okay. You would get negative 3 over 2. If you do 3 over 2 plus 6 over 2, that gives you 9 over 2. Okay? So those should be the two solutions right there. Right. See if right, that's example 7. Right. Check and see if that's what the book got for a thing. Oh yeah, that's exactly what they got. Yeah, yeah. They wrote this set notation form too. Yeah, look at that. You guys remember set notation? Yeah, same thing. All right, example 8. I think the book has 11 examples, so most of them. Solve with imaginary solutions. Ooh, I think they gave a complex example earlier. So example 8. All right, we got 3x squared minus 72x plus 465. This is all equal to 0. Okay. Uh, so my immediate thought is to divide everything by 3. Right? Is this divisible by 3? I see right away that it is. And here's how I know. If you add up all the digits and you get a multiple of 3, then the original number is also a multiple of 3. Like 4 and 6 is 10, plus 5 is 15. 15 is divisible by 3. So I can definitely do that. Yeah. And I'll get whole numbers, and this will all look pretty. Just divide everything by 3. So that gives me x squared minus, I think it's 24, isn't it? Yeah, 24. 24x. Okay. And this one, what is that? What is 465 on 3? It's 155. That's what it is, 155. Okay. So this is all equal to 0. Okay. Now I'm going to do what I've been doing the last couple of examples. Just subtract that 155 over to the other side. Okay. Uh, Here, I'll do this too. Right. So half of negative 24 is negative 12. And that value squared is positive 144. So I know if I have a plus 144 here, that would be perfect. This would be perfectly factorable and look squared. Right? But I also have to balance it on the other side. Okay, so now everything's restored. Everything's good. Okay, so got that net. Yeah, I think the internet's wigging out. Hold on. Let me see if this is gonna. Okay, no, I think we're still recorded. All right, we're good. All right, so what here? Well, this is definitely x minus 12 quantity squared, right? So x is x squared, bing, negative 12x, negative 12x, negative 44x, bing, negative 12, negative 12, 144, bing. It's all there. And then here, is this, what, negative 11? Is that what it is? Negative 11? Huh. Right. Right. So the fact that it's negative, I definitely see at this point we're going to get imaginary solutions. Okay, this isn't the final answer. It's just an important middle step. Got this squared form. Okay. So x minus 12, I just took the square root, equals the square root of negative 11, which is the same thing as uh, square root of 11 times I, or I times the square root of 11, if you like. Right? So the square root of negative 1 is I, so we're going to have an I. Right? Then if you, I should do plus or minus, right? Like plus or minus. Okay. Right, then I can add over 12, x equals 12 plus or minus. Right, let me see how the book wrote this. If they put the I before or after. Okay. Looks like your book actually did put the I before the root. All right, so I'll do I. I'll follow your book. I root 11. All right. So they wrote out two separate answers. They got 12 plus I root 11 and 12 minus I root 11. That's my plus or minus here. Same thing. Okay. Got that. All right. Example 9, right? Functions in vertex form. Vertex form. Um, okay. All right. Now this one, see, this is the first time I'm seeing y equals something in this lesson. It's not equal to zero, it's y equals. So that makes me think maybe like a whole parabola. You could eventually graph this on an x, y set of axes. Here, I'll do at least one of these examples. Let's do example A and see what happens. You know what? It's negative. Yeah, that's okay. We'll stick to this, right? Y equals negative x squared minus 12x minus 9. Okay. Now, my immediate thought is I'd like to multiply everything by -1, but it's not equal to 0, so not that simple, maybe. Flip the parabola upside down. Okay. But how about this? I can still group all this together and go on completed square, and I can factor out a negative anyway. So y equals, I could pull a negative out of all this. So that would be x squared plus 12x, right? And then I'll just tag on the -9 like later on, right? Yeah. Okay. Now, the next step I'm thinking is okay, I'm going to change this to brackets to make it really stand out. No special reason otherwise, right? Is uh, x squared plus 12x, right? See, like if I only had a plus 36, because half of 12 is 6, and 6 squared is 36. If only I had a plus 36 here, then everything in brackets would be perfectly like unsquareable. Right? You could do that, like right as a square of two terms, right? But now I have a -36 excess. So I have to restore balance by doing plus 36, right? And I still got this -9 out here. Okay. See, like I have -36 that's not actually part of it. So if I do plus 36, then this all zeroes out and leads me back to that. So everything's still balanced. So we're still good, right? But the advantage of having a 36 there, like I was saying, is that this is now a square of a binomial. So you can do x plus, all right, half of 12 is 6. It would look like that, right? Now, I still got this bit here. So 36 minus 9, that's plus 27, right? Okay. That should be what they're looking for. I'm pretty sure. All right, let's see over. Did they not? Um, okay, so they left a lot of blanks here. Let me make sure this was kind of following their process. Yeah. Okay. Right. So there are a lot of blanks, but I think that's pretty much what they wanted you to do. Right. And that would be vertex form, right? Their vertex at. Do you guys see what a vertex is going to be? It's a coordinate. It's at -6, comma 27. Okay. So if you were to graph this, right, you could sort of whip off a parabola fairly quickly, or at least a basic idea. Okay. So I got x-axis, y-axis. Okay, so this is not going to be the prettiest graph I ever drew, but if you're at -6 on the x-axis and at 27 on the y-axis, there'd be a vertex right there, right? Because you could, if you plug in -6 here, this bit would zero out, leave you with 27. Okay, so it's okay. Okay. And then I do see it's an upside down parabola. So some version of an upside down parabola. Okay, yeah, that's really basic example, but that graph looks like that. All right. And example 10, determine the vertex and axis of symmetry. Okay, it sounds really similar to what we just did. Yeah, there's a y equals and the whole thing. Okay. So I think this is very, very similar to what we just did. Y equals 3x squared minus 12x plus 5. Okay. So right away I see these terms I could pull 3 out. So 3, and then I have an x squared minus 4x. Right, now I still have this plus 5 over here. Okay. Now, if only I had a plus 4 here, because half of -4 is -2, squared is 4 here. Maybe I should do some peeking to make it sort of stand out. If I had a plus 4 here, this would be factorable, and it would be the square of a binomial. Okay? But look what I just created. It's a plus 12, because isn't this 3 also here? So 3 times 4 is 12. So I have 12 excess. So I have to also subtract off 12 to balance the equation. So it looks like that. Okay? So to rewrite this, I got 3. Okay? Now, all this in brackets, I can write as the square of a binomial. It would be x minus 2, all being squared, because x squared. -2 is -2x is -4x. -2 times -2 is +4. Yeah, it fits. Same thing. Okay? Now, what about all this out here, though? That'd be -7. So I think this is the equation right here. That's the equation. Okay? The vertex would be at x would be 2, and y would be -7. Right? So then say find the vertex and axis of symmetry. So here, once I draw this out, it will be really clear what the axis of symmetry is. So I got x-axis, y-axis, 1, 2, 1, 2, 3, 4, 5, 6, 7. There's 2 comma -7. Right? And it is a tall skinny parabola, right? It's like stretched by a factor of 3. Like I wonder what the y-intercept would be. That's where x is 0. So if I plug in 0 here, this would be -2 squared is +4, so there's 12. 12 minus 7 is 5. 1, 2, 3, 4, 5. So kind of somewhere there, right? Something crazy. Right? So yeah, so this would be a tall skinny parabola that does something basically like this. It's basically the shape. Yeah, that would be it. Right? All right, so here's the vertex at 2 comma -7 as a point. Okay? And furthermore, wouldn't the axis of symmetry be this line right here? Right? Doesn't this line act like as a mirror? Right? Could you put a line here and make that a mirror for your parabola? Right? That's what that would be. Right? So the axis of symmetry, I'll spell that out. Axis of symmetry. Well, it's a vertical line, so it's x equals, and the x value is 2. So it'd be at x equals 2 is the equation of that axis of symmetry, that vertical line. And so let's see if that's also what the book says. Um, okay. Well, they did get the exact same equation we got, right? And then they left some blanks after that, but yeah, that's exactly what it would be. Okay, so same thing. All right, so we did. And they got one more example, and then I'm going to jump into some of these book puzzles. Example 11, using quadratic functions. A firework is launched 1 foot off the ground at velocity of 128 feet per second. Write a functions for the situation. Write and interpret the axis of symmetry in the vertex. Right? Yeah. So I've seen some of these recently. So this is our physics examples. So example 11, physics. Right. So we're firing a rocket straight. Maybe we should draw a picture of this. Right. It says 1 foot off the ground. So the initial height is like 1 foot. 1 foot. Right. Then we blast this thing. It's going to go way up in the sky and probably come back down. And its height as a function of time will follow a parabola. This could be like a tall standing parabola. If there's like a time axis on the horizontal, something like that. Maybe it's like t or something like that. Okay. So this looks familiar. Here, spell exactly that. So height is a function of time equals -1/2 of Earth's gravity times time squared plus the initial velocity upward times time. Sometimes I do it that way for physics, plus the initial height. Right? You guys seen a few of these earlier in the module, and also you guys did a whole activity. This you guys remember we took those ball launchers outside, and you guys were launching the balls and did the calculation. This is exactly what you guys were working with. Yeah. So height is a function of time. Okay. So let's pop in the values. Um, all right. Now I can leave h of t by itself, or I could say y equals, I'll just leave it as h of t. Okay. So we'll make a whole parabola out of this. Okay. Equals. Okay. Now for g, I'm going to plug in 32 feet per second squared. Feet per second squared. I'll put the units once and I'll just drop the units after this and put the numbers there. The initial velocity up was 128 feet per second. So that takes the place of this v naught, 128. That's feet per second. T. And then the rocket started off, the fireworks started off 1 foot above the ground, 1 foot. So in place of this h naught, so the initial height, I put 1. And that's a foot, 1 foot, like that. So here's your equation. Right? So I can clean this up a little bit. So height is a function of time. Right? So if you're counting the number of seconds, you're like, what are how high is the firework after so many seconds? And it goes like this. Well, -half of 30. Oh, whoops. I missed my t squared. Point. A little t squared. Oops. Okay. So now we're good. Okay. That'd be -16. I got t squared plus 128t plus 1. Looks just like that. Yeah, that's it. Okay. Now, since the theme of this lesson is completing the square, let's do the same procedure that we've been doing, right? So we can look like complete square. We'll get it like vertex form and the whole thing. So I can factor -16 out of this. -16. Leaves me with a t squared, and then this would be minus the negative. So what is 128 on 16? Okay. nicely, it's a whole number. Okay, so 8, or, well, it's an integer, right? Okay, t minus 8, t. Okay, now I'll leave a little space here, because I still got this plus 1. Yeah, okay, kind of ran out of paper. That's okay. Okay. Now, why did I leave a gap there? Because I want to complete the square. Now, I know half of -8 is -4, and that squared is plus 16. Here, I'll switch to pink. So plus 16 right here, right? So now this is like factorable. I can make a perfect square out of everything in brackets, right? But the problem is that 16 times 16, so 16 squared, I've got -256 extra that I don't need to have. So to restore balance, if this is -256 extra, if I do plus 256 extra, that would restore it. And now all this bit zeroes out. It leaves me exactly back to the previous step. Everything's balanced. It's all good. So I have an extra 256, and that balances the expression. So next step, height is a function of time equals, okay, so I'll keep my -16 coefficient here. Then all those brackets is the same thing as t minus 4 quantity squared. Okay? And to show you guys how it works, I could FOIL. So f t is t squared, bing. O and I, -14 makes -18, bing. And -4 is positive 16, bing. Yep, it all checks out. Now I still have all this over here, plus 257. Okay, okay. So that should be what we're looking for. So this is the height of the firework as a function of time. We can just plug in whatever time we want here, but this is on like vertex form. If I come this vertex form, you can right away see how high the firework goes. It's this number right here. Okay? So, yeah, because this would represent the vertex of the parabola, or well, the maximum height value. Right? So if you want to, like, how high does the rocket go? This is the firework go. Oh, it goes up to 257 feet. Just like that. Is that what they got over here? Yeah. Okay. Again, they kind of broke it off halfway, but looks like their steps are pretty well aligned with what I have over here. So it's okay. Wait, did they ask for axis of symmetry and vertex? Okay. So axis of symmetry, kind of have a picture here. So like what's the time axis of symmetry? Yeah, that's to say at what time would it have reached the peak? Okay. This would be at t equals, well, if I put in a 4 here, like 4 seconds, as in 4 seconds, okay, um, that would represent uh, the time when it reaches maximum height, or like split this parabola in half. Okay? And the vertex is at 4 seconds and 257 feet. Okay, so this is seconds and this is feet. Okay, so there we go, vertex. Okay, and that represents this top point right here. Okay, so that. All right, there it is. There's everything. Everything you want to know about that firework. All right, so book puzzles. We're on page 171. See, I picked a bunch of days. Oh, I'll see if I can pick up the pace a little bit on these. Okay, okay. And then, I got more fireworks here. What I did with you guys? Got a reaction time. And then, I got a couple over here. So some word puzzles. I have to kind of map this out a little bit. All right, so what you do. And so number 1 on page 171. Page 171. So I got x squared minus 18x plus 81 equals 49. Okay, this looks like going back to the beginning. They're trying to help you out. Half of -18 is -9. -9 squared is 81. So you can just right away say x minus 9 quantity squared is 49. Okay, it says solve each equation. Okay, so that's the first step. But after that, you can go ahead and solve for x. Square root both sides. X minus 9 equals plus or minus 7. Right? Square root of 49 is plus or minus 7. X equals, and then add over 9, 9 plus or minus 7, which equals, well, 9 minus 7 is 2, and 9 plus 7 is 16. So X could be 2 or 16. There you go. Okay, number 11. 25x squared minus 30x plus 9 equals 96. Okay. Okay. First thing I'm thinking is, yeah, okay. This one was a little trickier. That's okay. We'll be able to work with this. Oh, wait a minute. Wait a minute. Can let me try something a little funny here. Can I believe this is just 5x and then work with it like that? Here. Like, what if I do this? What if I do 5x and then Yeah, okay. Half of -30 is -15. Let me try this. Let me see where this leads. Okay, I'm just trying something out here. Okay. So like if I square that, let's see what would happen. So if I FOIL that, 5x being squared is 25x squared. Bing. Oh, actually, wait, this is way too much. Because 5 times 15, I don't want 5 times 15. Let me change this to, um, how about 3? Scratch this. Let's do 3 right here. Okay. 5 times -3 is -15x, and then -15x is -30x. I'm thinking of FOIL, FOIL. Yeah, I haven't done this in a while. But this is 5x minus 3, 5x minus 3, and I'm thinking on my mind, FOIL. First term checks out, outside inside terms check out to this. Now the -3 times -3 is +9. Okay, that's why they did put a 9 here. Okay, so yeah, what I was thinking looked really tricky to start out with, and then I tried this method. Actually, it worked out really well in our favor. Okay, so I can pick up from this step. Here, I'll rewrite that just so it looks prettier. X minus 5, sorry, 5x minus 3 quantity squared equals 96. Okay, so okay, now pick up from here. So 5x minus 3 then could be plus or minus the root of 96. Now, 96, I know that's divisible by 4. It's 24 times 4. So let me do a little factor tree here. It's 4 times 24. 24 is 4 times 6. Now, 6 is 2 times 3, but those are both primes. Okay, but okay, what it can do, so 96 is 4 times 4 times 2 times 3. Okay, I know the square root of 4 is 2, and the square root of this 4 is also 2, or 4 and 4 is square root is 4. However you think of it. 5x minus 3 equals 4, plus or minus, and then plus or minus 4 to the square root of 6. Okay? Last couple steps. Add over the 3, divide by 5. So here, we'll do 2 separate steps. 5x equals 3 plus or minus 4 root 6, and then divide both sides by 5. X equals 3 plus or minus 4 root 6, all divided by 5. Okay, we got this right. Okay, ooh, okay, so a little trick right there. That's right. 16. I got x squared minus 8x plus 16 equals -36. Okay, okay, I'm kind of having a hunch this one might be imaginary. I glanced at the answers ahead of time, so I was trying to get some had a little bit different looking type answers. Okay, so right. Oh, yeah, yeah, they're helping us again because half of -8 is -4, squared is 16. So it's all right here. Just write it for us. X minus 4, quantity squared. Boom. Okay, so that's negative. Okay, yeah, I see what's happening. So x squared, bing, -4, -4, -x, bing, -4, plus 16, bing. It all works. We're all good. We're all good. So square root both sides. X minus 4 equals, and here's where we're taking the square root of a negative. So plus or minus root -36. Now, if I break this down, factor tree, I got a -1 and a 36. Now, 36 breaks down to 4 and 9. Now, 4 and 9 are both perfect squares. That's 2 and 2, and 3 and 3. So I could think of it this way. X minus 4 equals, okay, I'll still have a plus or minus. Okay, and it's all of this. 3, 3, 2, 2, and -1. Okay. And so square root of 2 and 2 is 2. Square root of 3 and 3 is 3. So that makes 6. Okay. And then I still have an I left over. Okay, so it should look like that. Last step, add over 4. X equals 4 plus or minus 6i. Okay. That will be the answer. Number 20. Find the value of c that makes the trinomial a perfect square. Then write the trinomial as the square of a binomial. Oh, okay. I think we did one like this earlier. Looks familiar. Minus 14x plus c. Okay. So if I want to write it in this form, like x, well, it would be x minus 7 quantity squared, wouldn't it? Okay, it would be that. Okay. Um, so, right, x squared minus 7x minus 6 minus 14x. But this would be plus 49. Yeah. So therefore, c equals 49. That should be like x squared minus 14x plus 49. And then this is writing it as a square root binomial. Okay. So this and this, so c is 49. Okay, there you go. Um, that was 20. Okay. 26. Solve each equation by completing the square. So 26. Got x squared plus x minus 6 equals 0. Okay. Hmm. Okay. We work with this first. Okay. If I do x plus a half and then square that, okay. Let's see, x times x is x squared. All right, 1/2 x and 1/2 x makes x. But 1/2 squared is 1/4. So I have 1/4 too much. So I have to restore balance by subtracting a quarter. Okay. Now I've still got this minus 6. I haven't touched it all, and this is still equal to 0. Okay. Okay, so yeah, that's one way to complete the square. Okay. Um, all right, so x plus 1/2 quantity squared. Guys, could this kind of guess? Could I do minus 1/4? What is 6 in terms of quarters? 4 over 4? Is that like 24 over 4? And I can combine this and make negative 25 over 4. We could do that. X plus 1/2 quantity squared minus 25 over 4 is equal to 0. I could add over 25 over 4, x plus half quantity squared equals 25 over 4. Right. Oh, look at that. 25 and 4 are both perfect squares. So when I square root, hey, this actually ends up looking all right. Plus or minus 5 over 2. Then last step, add over, or no, subtract over 1/2. That's what I should do. X equals negative 1/2 plus or minus 5 over 2. Okay, maybe that could work. I could also say this. Okay, negative 1/2 minus 5 over 2 is negative 6 over 2, which is negative 3. Negative 1/2 plus 5 over 2 is like 4 over 2, which is 2. Let me double check my work on that. I think I did that right. Negative 0.5 minus 2.5 is negative 3. Or if I did plus, yeah, okay, so that's right. Um, Actually, this is kind of ugly. I like this way already. So negative 3 and 2. That actually, bing, that looks much prettier. Yeah, let's do that. Okay. All right, number 31. The dimensions of the cube are reduced by 4 inches on each side. The surface area is now 864 square inches. What were the dimensions of the original cube? Hmm. Now, a word puzzle here. There, straw this out like a cube. Like a cube, right? Okay. So there was, right. It says reduced by 4 inches. Okay. Maybe I'll call this original side like x. Okay. And if this is a cube, that means that this is also x, and this is also x, right? So length times width times height. How would we get x times x times x, right? And if we reduce by like 4, say 4 inches, well, you could kind of imagine. Suppose this was like kind of transparent. Okay? Or we get a smaller cube that's only maybe when it comes to like something like this, if you kind of see through it, right? But this is like x minus 4, and this is x minus 4, x minus 4, and then this is x minus 4. Okay, so right, so x minus 4 of the cube. Okay, and now the surface area of the new cube is 864 square inches. Well, I know surface area of a cube is like if you take one face and then multiply by 6, because there are 6 faces. Isn't it true? Like roll a dice on a die, there's 6 faces, right? So it'd be 6 times a face squared. Right? And we were talking about the new, like smaller cube down here. That'd be x minus 4 squared, right? Because here, x minus 4 times x minus 4, like this width times this height gives you one face of the new cube. That's x minus 4 quantity squared. And there would be 6 of those faces. So there's 1, there's 2 is over here, 3 is on top, and then there are 3 faces kind of behind, right? 4, 5, and then 6 down here at the bottom. Okay, so I got 6 faces. And this is equal to 864 square inches. Question is, what's the original dimensions of the cube? Oh, and conveniently, how I mapped this out, the original dimensions were x by x by x. So we can just solve for x. Yeah, that's it. Okay. So there's the setup. I translated this word question into math, and now we just need to solve for x. That's it. Solve for x. I can divide both sides by 6, right? Can I take 864 over 6? 144. So x we're solving for minus 4 quantity squared equals 144. Keep that, that'd be true. That's a perfect square. So x we're solving for minus 4 equals, we normally say plus or minus 12, but since this is a practical example, it probably doesn't make so much sense to have negative sides. So I'm just going to pick the positive value, because if I had negative 12 and added 4, it would still be negative. That wouldn't work. So x would be positive 12 plus 4. I'll spell it out. 12 plus 4. Right? X is 16. Okay. So one side is 16. Therefore, the original dimensions are 16 by 16 by 16. Okay. Length with height. Okay. 16 long, 16 wide, 16 high. Okay. That was the original cube. All right, there we go. Number 50, fireworks. Hey, it's another fireworks example. Ooh. I see that height is a function of time. Suppose the firework was launched 2 feet from the ground. Before it was 1 foot off the ground. Now it's 2 feet off the ground. And has a velocity of 96 feet per second. But it's the same physics format. So number 50, fireworks. All right, here, I'll draw the same picture I did before too. I've got a platform that's like 2 feet above the ground. So this right here is 2 feet. Got the rocket. It's going to launch way up in the sky and come back down. And this is like a time axis here. And this could be your height axis, right? How high does it go as a function of time? That would form a parabola. Yeah, that's it. Right, so we got height as a function of time equals negative 1/2 gravity field times time squared plus the initial velocity times time plus the initial height. Yeah, that's it. Just what we did before. Okay. So height as a function of time equals negative 1/2. Now place of gravity. Well, if we're using American units, we're looking at 32 feet per second squared. In my physics class, we usually stick to metric. This could be like 9.8, or sometimes my students around at 10, but we're going to use feet per second squared. That's why it's 32. Right, times squared plus, and then they told us it blasted at 96 feet per second. So it goes right there. I got a T. And the initial height was 2 feet. So look at that. It cleans up one word way. I'll say height as a function of time equals half there to negative 16 t squared plus 96t plus 2. All right. So I dropped the units just to make it a little cleaner. But that would be it. Now, what do it wants to do with this? Write a function to represent the situation. Okay, so that's question A right there. We just did that. Boom, done. Uh, Rewrite the function in vertex form. Vertex form. Okay, well, that would involve completing the square. So, let's see. This might be a few steps. Like, spin all along. I can pull um, I'll pull a negative 16 out and see what happens. Okay, just did this bit. So I got a t squared. Now, 96 over negative 16 is negative 6. So, look like this. Uh, wait, t. Yeah, I still got a T. Right. Now I'm going to leave a little gap right here. Leave a little gap. Right. And I still got a plus 2. Right. So completing the square. And a little bit different ways to do this next step. What I'm thinking is half of negative 6 is negative 3. Negative 3 squared is positive 9. So I really need a plus 9 right here. Right. If I only had a plus 9 right there, I could very quickly put this in like a squared binomial form, which is what I want. But the problem is that I have negative 16 times 9 in excess, 16 times 9. So I need to restore balance by adding 144 over here, because that's what 16 times 9 is. So if I had negative 144 here from these, and I add 144, that balances the equation, and it leads me back to the original statement. So we're good. Okay. So next step, height as a function of time equals negative 16. I got, okay, now here's where I'll go ahead and do the rest of it. T minus 3 being squared. Because watch this. T squared, I'm thinking FOIL, FOIL. T squared is T squared. Negative 3t, negative 3t makes negative 6t. And negative 3 times negative 3 is positive 9. So it all works. Okay. Right, then out here I have plus 146 from the left. I think that's probably what they want for a vertex. Yeah, that would be vertex form right there. Right, vertex form. Right, there it is. And finally, they want something else here. Find the axis of symmetry and the vertex and interpret their meaning in the context of the situation. Right? So vertex is at 3, comma 146. Right? And axis of symmetry is at t equals 3, and that'd be seconds. Okay. Now, what does that mean? That means like this peak point right here happens at the 3-second mark, and the maximum height is 146 feet. So how high does the firework eventually go? It goes 146 feet up, okay? And that's at the 3-second mark. Okay, so everything leading up to 3 seconds. So times 0, 1, 2, 3, the rocket is on the rise, and then you have an axis of symmetry right at 3 seconds, and then everything after 3 seconds. So 4, 5, and 6 seconds, it's falling back down to the ground. That's what that means. All right. I think I just picked two more, no, three more puzzles to do with you guys. So let's do these three more. All right, 62, reaction time. Yeah, so I saw this and immediately made me think physics. Tella was eating lunch, sees her friend Jory approach. The room was crowded. Jory had to lift the tray to avoid obstacles. Suddenly, a glass on Jory's tray tipped and fell off the tray. Tella leaned forward and managed to catch the glass before it hit the ground. The height and feet of the glass and after t seconds was given by this expression, h equals negative 16 t squared plus 4.5. Okay. Or here, I'll write that down. So h, and it could be as a function of time if you like, equals negative 16 t squared plus 4.5. Okay. I know what that means. So this is half of Earth gravity in terms of feet and seconds. So we're working in terms of feet seconds. I don't see a t term. Only a t squared and constant, which means the glass started from rest. It didn't go like shooting off the tray, it just like fell off the tray. And this 4.5 represents like 4.5 feet off the ground. So here, if I draw a little picture, it's like this tray, this glass is like about to tip off. Maybe like here's the ground down here, right? And it goes, it pretty much falls from rest. Okay? And this height, this initial height, so I'll call it h naught, initial height was 4.5 feet. Right? That's that interpretation for that. What do they want here? Keller caught the glass. When it was 6 inches off the ground. So 6 inches off the ground. Is that like 0.5 feet? Okay, so at 0.5 feet off the ground. So at 0.5 feet, because that's what 6 inches is, right? 0.5 feet, half a foot. Right? Then how long was the glass in the air before she caught it? That's the same solve for t. Yeah. Right. So in place of this h of t right here, I'm going to put 0.5 feet because that's what 6 inches is. So say equals 6 inches. Okay. Equals negative 16 t we're solving for squared plus 4.5. Oh, this is feet. This is feet per second squared for that matter. Right? Here, yeah. Uh, I think this looks like straightforward algebra, right? So subtract over 4.5. So negative 16 t we're solving for squared equals, now 1/2 minus 4.5, isn't that like negative 4? Right? Divide both sides by negative 16. T squared equals negative 4 over negative 16. The negatives are going to cancel. This is the same thing as 1 over 4. Square root both sides. T equals, now normally I'd say plus or minus, and square root of a quarter is a half, right? Oh, whoops, sorry, whoops. Which is plus or minus 1/2, right? But it doesn't make sense to think about like catching the glass backwards in time. So just be 1/2 of a second. There you go. Right. Yeah, I have my students in physics do some. Oh, actually, I had you guys do that exercise. You guys remember that day? I had you guys pair up with a roller, okay, and so this is two different people, my left hand and my right hand. Okay? So one person dropped the roller and the other person caught it as fast as they could. And depending on where you caught it, it could measure your reaction time. You guys remember that? And it went like this. So here's a little extra thought. The height the roller fell is 1/2 gt squared. So if you solve for t, and we're skipping a few steps, it ends up that t equals, say, 2h divided by g, the square root. Works like that. Right? Okay, regardless of what kind of use you pick, metric or American or whatnot. Okay? And most of you guys got your reaction time was about zero point 0.2 seconds. And this was like 0.5 seconds. Yeah, I think that makes sense, right? You see it, you gotta react quickly, you dodge, you grab the glass before it hits the ground. All right. Let's see if I'm started. Maybe. All right, number 70, deck design. The Rayburns current deck is 12 by 12 feet. Okay, 70. So we're going 12 by 12, right? So 12 feet by 12 feet. 12 feet this way and 12 feet this way. Okay, what now? They decide they would like to expand their deck and maintain its square shape. How much larger will each side need to be to have an area of 200 square feet? Because right now it's 144, isn't it? It's 12 by 12 is 144. Okay. But they want to take this all the way out to where the new area is 200 square feet, like this whole area. Okay, so I'll say A equals 200 square feet. Right? And say how much longer will each, or how much larger does each side have to be? Well, it looks like they expanded it by some amount x, and if they maintain the square, that would be true in both dimensions. Okay? Yeah, I think I'm seeing the picture come together. Let's make an equation out of that. So area would be width times length, okay, which would be 12 plus x and then 12 plus x. And it has to come out to 200. And this is feet and this is square feet. Yeah, so but here, I will you know what? Okay. I almost said let's FOIL that out, but I changed my mind. Okay? Because the whole theme of this chapter is about completing the square, and it pretty much is in that form already. So we can actually solve it faster by, like if I foiled it and pushed it through a quadratic, that would actually be more steps. This way's faster. I'll just square root both sides. So x, we're solving for, plus 12 equals the square root of 200, which is the same thing as, isn't 200 2 times 100? And square root of 100 is 10. So it's the 10 root 2. It's the same thing, same thing. Right? And then subtract off 12, because 10 root 2 is like 14.14. Here, I can show you guys. Square root of 200 is 14.14. Or if you like 10 root 2, it's the same thing. It's 14.14. So I can subtract 12 and still have a positive number. So x equals 10 root 2 minus 12. This would all be in terms of feet. Right? That would be like an exact answer. Right? Or I'll say approximately that minus 12, 2.14 feet. Right? That's maybe more practical, right? Right? Like if you went down to Home Depot, like, oh, I want my deck to be 10 square root 2 minus 12 feet. That would what? Right, that's 2.14. Oh, okay. I can work with that. All right. One more I got highlighted. So let's knock this one out. Volume. Ooh, so now it's on about 3 dimensions. We got a piece of sheet metal has a length that is 3 times its width. They pause right there. They draw what they got. Okay, so they are giving us a little picture too, so maybe I can kind of copy down what they got. Actually, let me read ahead a little bit. Make sure. Okay, length is 3 times its width. If this is length and this is width, maybe something like that. It is used to make a box with an open top. Right, so box with an open top. I'm already thinking this could look kind of like this, couldn't it? A box with, okay, there's a general box and it has an open top. Maybe it looks something kind of like that, right? You can kind of see down the box. You could put something in. Um, by cutting out a 2 inch by 2 inch squares on each corner. Oh, just like they gave us right here. Right, and then folding up the sides. Define the variables, write the function that represents the volume of the box. So in cubic inches, what are the dimensions of the sheet metal that results in a box with exactly uh, okay, so I think one at a time here. Let's take this. Okay, so let's get their picture. Right, so they chopped off these corners. That's 2 inches by 2 inches. Here, I'll just call it 2. Right, so everything refers to inches. Right, so all these numbers are in terms of inches. 2. Right, so they chop that out. Okay. They said the length is 3 times the width. So if this is width, I'll call it W, and this is length, maybe call it L. Well, L is 3 times W, so I could sort of like substitute that probably down the line. Right? Right. And then we're looking for a volume. Okay. So let's do volume maybe is a function of width. Maybe how about that? Volume is a function of width. Could be and here I can work off my 3D model. Right, so it's this length times this width. Actually that's not exactly true. It it'd be length minus two, wouldn't it? Length minus four. And then this would be same idea here. This width minus two minus two. Right? So like if I fold up these sides, you guys gotta think in 3 dimensions on this. Right? If I fold up these sides, then the base of this box is now just this hashed in area right here. That's the new base, okay? Which is not L by W. It's L minus two with L minus four, and then same thing width minus two or width minus four. Okay? And the height, this height right here, would be uh, would be this, or this if you like, which is just two. So this is just 2 inches. Okay. Okay, so we get rid of volume as a function of width. I'll just say volume in general. Right. Right. So just start from the beginning. So it'd be L minus four, uh, and then width minus four, and then two. Right? Because this would be the length of the 3D box, which would be L minus two. That's where I got this from. And the width of the 3D box would be W minus two, or W minus four. And the height of the box is 2 inches, right? Just two. There it is. Right. Now, if I want to say volume as a function of width, right, that's where I can take this right here, L is 3W, and substitute it right there. Maybe this should have been L. There. So I can say 3W minus 4, W minus 4. Okay, and then I got a 2, right? Let me go ahead and expand this whole thing out. I think I do have to FOIL this, FOIL, and then bring this after the fact. So volume is a function of the width is, so you got 3W squared minus 12W minus 4W, and then plus 16, because 4 by 4, right? And the whole thing, I still got this 2 over here. I can combine this and make negative 16W. Volume is a function of width equals 3W squared minus 16W plus 16, right? And the whole thing is times 2, right? Uh, hmm, yeah, right. It's gonna be a little tricky, isn't it? Yeah. Oh, that's okay. We'll be able to make do. All right. So I'm going to go ahead and pull a 3 out of this. So volume is a function of width equals, okay, so I'm going to pull, actually, let me just instead, let me distribute the 2 first. Right, 6W squared minus 32W plus 32. Okay, so I think that was something. We'll pick it up from there. Okay. All right, I'll go ahead and pull a 6 out of this whole thing. Volume is a function of width equals 6. And then I got a W squared. Okay, now here's where things can get a little weird. Right, 32 over 6, like that, or 16 over 3 if you like. 16 over 3. Okay, and I'll leave a little gap. Okay, and I still have this plus 32. Okay, so now this is looking a little more familiar. A little bit wacky factor, that's okay. Okay. Now, in peaking, I'll switch this. It'd be really nice to be able to complete the square if I had plus right here, 16 over 3 divided by 2 is 16 over 6 being squared. 16 over 6, and if I squared that, which is like 64 over 9, right? Because half of this would be, actually, maybe that would be an easier way to say it. Half of this is negative 8 over 3. Squared is 64 over 9. Yeah, right. Right. But that'd be times 6. So 64 over 9 times 6 is like this much to excess. So I also have to subtract that off. And times 3, that would be minus 128 over 3. Okay. Okay. So yeah. So by having this times 6 and then I subtract it out so it balances. Right. So now this is so on. Okay. So I balanced my equation. Okay. All right. Real challenge question here. That's okay. We're getting closer. So volume is a function of width. Then equals, okay, I got the 6. But now this is ready to be in that factored form. W minus, okay, now this would be 8 over 3, and then quantity squared, just like that. W squared, then 8 over 3W, 8 over 3W, that, And that's where it's at. Boom. Right now, 32. Okay, 32. Can that be 96 over 3? It's the same thing. And then minus 128 over 3 I still got from here. This is 32. It's the same thing, but on a common denominator. Okay. So volume is a function of width equals 6w minus 8 over 3, quantity squared. And then what's 96 minus 128? This is minus 32 over 3. Okay. So I think this is the factored form of the volume. So yeah, that's volume is a function of width. Um, Define variables and write a quadratic that represents volume of the box. Okay, so I think it could be this right here. And then what are the dimensions that would result in a box with a volume of exactly 1.125? So right here, if I replace with 1.125, I could solve for W. And then since I know L is 3W, I could get the dimensions of the original sheet metal, or the metal sheet. Okay, so we get it. By the way, this is the same thing as 9 over 8, I think. Let me double check. Is that 9 over 8? Yeah, it sure is. So maybe that's helpful. I don't know. Okay. Equals 6w minus 8 over 3, quantity squared minus 32 over 3. Okay, yeah, we're getting to really wacky territory because the common denominator here would be 24. Here, let me see what it get on the calculator. I'm just going to add this over plus 32 over 3. Okay, yeah, so that's 283 over 24 equals 6w minus 8 over 3 quantity squared. Divide both sides by 6 is 2. It's getting really weird. Okay. 283 on 144 equals w minus 8 over 3 quantity squared. Okay. Square root both sides. What's the square root of 283 on 144? Yeah, I'm just going to finish this out with decimals because, okay, let me try this. 1.402. Okay, so now I'm starting to round a little bit. Equals w minus 8 over 3. Okay. What is 8 over 3, by the way? Yeah, like that. Yeah. Let me say like plus or minus. Oh, I think I'm getting this right. Okay. So 1.402, say plus 8 over 3. So W could be 4.07, or what's 8 over 3 minus 1.402? 1.26, right? Something like that. Interesting, I'm getting two possible solutions out of it. That didn't seem quite right. Okay, let me go back and check my original box here. Because L had to be 3W, right? So L, which is 3W. Okay, what if I triple each of these? 4.07 times 3. Uh, 12.21 or 1.26 times 3 is 3.78. Okay. Now, they did say the volume had to be, um, okay, I see. I see what's going to happen. L can be, yeah. Okay, okay. So I was a little uncomfortable with this because it's like, well, why would there be two solutions? That doesn't make sense. But I see. Right? These both don't work because width has to be more than 4 inches, right? That's a constraint. Width has to be more than 4. Because if it was 4 minus 2, it would go down to 0, and that wouldn't work. So this 1.26 doesn't work, which means this 3.78 length also doesn't work, which it wouldn't anyway, because length also has to be more than 4. Okay, so it's got to be this right here. This got to be the dimensions of that sheet metal. Okay, so last thing I can do, let me make sure this actually does work. So I'm getting these dimensions right here. If I put this back into the original situation and I think about like a 3D box, I should get about 1.125 cubic inches. Right, so let's say put it. Right, so the length of the box would be L minus 4, which is 12.21 minus 4. The width of the box would be W minus 4, which we talked about earlier. So that'd be 4.07 minus 4, which is like real skinny. That still works, I guess. There. And a height I want to be, well, it's got to be 2, okay, like as a fixed number. Okay, so if this says something pretty close to 1.125, because I did round a little bit, then we're good. Oh yeah, yeah, 1.14. Okay, that's close enough because again, I did round a little bit here and it's a really skinny width, so I can believe that. Yeah, so this is what they're looking for. All right, there you go. There's the dimensions. Woo! All right, so we ended on the challenge, but it all worked out. There you go. All right, so there's 3-5.